The seminar group here. Today is the first time I've ever ventured to speak in front of other people standing up about motivation. So,
Sorry,
and I always change my title and stuff. So yesterday when I was working on this, I decided to call the talk "Motivation as an Emergent Phenomenon." So what the heck does that mean? But first, a disclaimer. I am not a motivation researcher, so I should probably sit down now. But I am a learning and cognitive scientist. I do design learning environments. And I think as, in various studies and various things I've been involved with in my career, getting students to learn or to not learn, I think, it gives us opportunities to engage, at least informally, in my case, since I don't make motivation as a specific focus of inquiry. But I think that one gets some insights, particularly if you're trying to get students to learn some things that are particularly difficult and hard to understand. That there are some things about motivation that probably pop up periodically. So. But first I thought, since I mainly study learning, I thought I would pull out what when I look at it now, is a definition of learning that I had put into my educational psychologist paper with Manu Kapoor and Peter Ryman as a definition of learning. And then from that we can consider some definitions of motivation. We regard learning not as something that is, such as receiving instruction or acquiring knowledge, but rather as something that emerges. We define individual learning as changes in human cognitive processes involved with the encoding and capacity to manipulate and engage with symbolic representations, formalisms, and sociocultural practices that emerge from interactions with a variety of complex systems an individual may experience over time that lead to enhanced performance in intellectual, physical, and affective realms of life. Now, rereading that again, it's clearly a sentence that's too long, and I probably, if I was going to change it now, I would probably say we don't necessarily. You can learn stuff, and it may not mean that you enhance your performance. You can learn stuff that's not particularly helpful. You just learn a bad habit. But still, we were trying to kind of have something that would be speaking both to aspects about individuals and characteristics that are relevant for how people think and how people learn, as well as the context in which we learn. And we think that complex systems, which has a variety of conceptual perspectives and so on that allow us insights into macro and micro levels of systems and interactions across those. So with that as a overly long definition, let's see if we can get something a bit more pithy with motivation. Now, I was really trying to see if there's a 2017 Cambridge Handbook of Motivation or something that would bring things up to the present, but it seemed that most of the things where I was trying to get definitions of motivation and so on really go back in 15 to 20 years. I mean, intrinsic, extrinsic views of motivation go way back. But I thought that these are probably useful for us to maybe focus in on now. The notion of extrinsic motivation, of course, being that someone's engaged in an activity that is done in order to attain some separable outcome, is how I came across the Ryan and Decky paper, Classic Definitions and New Directions about motivation. And so that's fine. We do something because if we don't do it, we want to get a grade. It's good to have a better grade than not a good grade. You don't want the teacher mad at you. You don't want your parents mad at you. So you're doing it because you don't really care what you're doing, except that you want to have a separate outcome that you would perhaps find advantageous, or to avoid one that would be negative. Intrinsic motivation, an activity that's being done for the enjoyment of the activity itself, rather than its instrumental value. And in their paper, which is a reasonably good paper, I think, and they kind of dive in a little bit more about both extrinsic and intrinsic motivation. But in a little figure that they had in there, which I'm sure that you can't read, but I circled one aspect of under the extrinsic motivation that talks about the salience of the extrinsic rewards or punishments, compliance, reactance. And as aspects under intrinsic motivation, it's interesting, the one that most people would say is good, we want students to be intrinsically motivated. They just have a single little box here. The kind of motivation that most of us would say is not so great. We want to move away from extrinsic motivation. They got a lot more stuff that they're talking about, so that's of interest. But under intrinsic motivation, again, interest, enjoyment, inherent satisfaction. Okay, so that's fine. A lot of people have been using this kind of views of motivation, and we try to get students moving from being extrinsically motivated to really learning, learning how to love to learn, and they're doing it because they want to do it. So, so there's this notion that comes across in this kind of theorizing that intrinsic motivation is something that's internalized in the individual. Okay, and extrinsic, of course, is something that has not been internalized insofar as it's internalized. You know that if you do a certain thing, something good might happen, or if you do something or don't do it, and something bad might happen. I guess you've internalized that. But this is the good motivation. This is the not so good motivation. But both of these, though, there's a notion that motivation is conceptualized as something that is. It's a thing. It's a factor. You have it or you don't have it. And where this ties in with my definition of learning, I think for many people view learning as something that I've learned this information, I've got this stuff, and it went from the teacher and it's now in the head of the student. We've got the stuff now and it's been moved around. Something that is. And you have it or you don't. You have the knowledge or you don't. You have the motivation or you don't. But what if we view motivation differently? What if we view it not as something that is, but rather as something that emerges? And the notion of emergence is one of the key constructs in the study of complex systems and in the field of complexity. The idea that you have a system that's made up of elements or parts that are interacting with each other. And out of those interactions and feedback mechanisms and self-organization and so on, out of those interactions, you see something, a pattern emerges. A feature of the system at a micro level, something emerges at a macro level. I'd like to use the example of a traffic jam. You've got cars that are speeding up and slowing down, but they're basically moving, left to right most of the time. But when you have enough of them, and under certain circumstances, all too frequently in the modern age, traffic jams emerge. If you look at the traffic jam, though, the pattern that emerges of the traffic jam propagates backwards. So there's nothing in the individual elements of the traffic jam at the micro level that are going backwards, but something has emerged, something that's got different qualities, different characteristics. And this is one of the fascinating things about studying complex systems, because one of the key things you should take away from that is you can't just break systems down into smaller and smaller units and assume you'll be able to understand how this overall system itself might behave. But is motivation such a thing? Does this notion of emergence and motivation matter? So what I thought I would do is, now some of you have heard me speak about this particular study in the past, so but some of you haven't. So this is I thought I would take kind of a brief overview of what we did in a study that was published in Learning Instruction last year. Lena was one of the co-authors on this, as was Manu Kapoor. And this was a study where we had students learn about the scientific complexity of climate change. Now, complexity ideas are really not taught in the K-12 curriculum. they're actually pretty much not taught at university. Most students would be exposed to more kind of systematic consideration of ideas about complex systems, at least over the last few years at the postgraduate level. We are seeing that start to change in the United States. Next generation science standards, having students learn about complex systems is a key part of what is now being rolled out for science education in the United States. So we were interested in studying this. This is actually a project that was funded by both the Australian Research Council and the New South Wales Department of Education. It was a study that we initially got funded back in 2010, and so sometimes things kind of roll out slowly. We had a 4-year study, and we incrementally were kind of changing things and so on. And so what I'm going to be reporting here was the last year of the study, and then by the time you roll out the conference version of the papers and this and that and send it off to journals and revise things and stuff. Anyway, so we finally got the final version of this in the number 4 ranked journal in the field Learning and Instruction paper published last year. Now, this particular study, we had students using 2D computer models, agent-based models, in particular NetLogo, and we were working with Year 9 students to have them learn about selected ideas, kind of core ideas about complex systems, and then how those relate to understanding climate systems. And and then we developed some computer models of these, so students could be doing computational experiments of the Earth and what happens when we put 6 gigatons of carbon into the atmosphere every year. And it's not good, but you can see it. It's not. It's real. Now, this was the year 4 study that we did. The previous year, we had done a study where we used a learning design called productive failure, which many of you know about. For those of you that don't, this is a learning design that was initially proposed by Manu Kapoor, who's at ETH Zurich now. I knew him when we were both at the Learning Sciences Lab in Singapore. And we had some really nice learning outcomes using this productive failure as a learning design and with the students involved with the models. And I guess maybe I should have flip-flopped it, but the kind of key thing about productive failure, to kind of simplify it a bit, but you have students do something first. They're working on some problem or some issue. Okay, and I've been calling these challenge problems, let's say when I'm working with teachers and students. And you delay the teaching. Okay, so they're working on some problems. For us, it was maybe 10 or 15 minutes collaboratively, and then the teacher would be providing the instruction. And in that year 3 study, we interviewed teachers, and I said, wow, I think the students really are liking this approach. They're really doing well. I think they're understanding it. But one teacher said, but I'm sure they'd learn better if I taught them first. And we spent a whole bunch of time on teacher professional development and stuff about productive failure, but fair enough. Direct instruction really is, I would say, probably the most common teaching approach in the world. Universities, we have our lectures, and then you have a tutorial. You teach first, and then you go do some homework, you practice it, you do something with it. Somehow we got to give the kids the information, and then we got to have them solidify that. So, that's what it is, you teach first. So what we did in this study is we took what we had in year 3, which had worked quite well, and then we just basically took the same lesson scripts that had been used in a delayed fashion here, and we had 2 classes where the teaching was done initially. Then it was the same amount of time, the same challenge problems, same computer models. So we'd have the kids working collaboratively in pairs, and they could also talk to their neighbors. And then we would have the teaching delay. This is Dr. Paul Stokes, who was one of the teachers there we worked with and who actually programmed the climate models that we used. And then with Teach First, as I said, teaching the same stuff, doing it first. I was trying to be cute and I flipped the image, but anyway. And then the kids would be working on the models. So this particular school, it's a selective stream school, all girl. They're really brilliant young women, and they do really well in science. In all their subjects, I'm sure, but all these students were quite good in science, very interested in science and so on. Okay, so we have 4 days focusing on different things. We have pre-test and post-test. Now, what I put up here is kind of the framework that I've been kind of settling on, that I'm talking about levels of knowledge, and then how that relates to assessments. So those of you who are Andy DeCessa fans know that he talks about knowledge in pieces, students are experiencing various things in the world, but it's not kind of organized the way experts do. So I would call that a level 0, knowledge in pieces. And I'd say that what happens typically in school is students get to a level 1. They get to repeat things. They learn stuff, typically from a lecture or from a book, and they get good at repeating it. And we test them with things like multiple choice items and short answer. Okay? That's assessing factual information, declarative knowledge. And that's really emphasized in schools. For many students, though, they never get to level 2. Often that's not unless you have a really great teacher pre-university, but typically at university, though, we need to get students to get to a level 2 to be able to explain things. How or why do things work? I'm kind of lumping explanatory knowledge. Why did that jump over?
I think you touched the bullet.
Yeah. Okay,
It's
that's right.
interactive.
I got it.
That's a trick.
I didn't know it was that smart. Yeah, so I'm kind of lumping in explanatory knowledge, procedural knowledge on level 2. I kind of use this framework when I'm talking to general non-academic folks too. But being able to explain things really does require a much better understanding, conceptual understanding, linking into the declarative knowledge. The level 3, being able to apply it. This ability to transfer, use the knowledge that you have in new situations, new problems. I would suggest that this remains a significant problem even for graduates of universities. You hear this said quite frequently. Companies will hire graduates from top universities and say it takes 2 or 3 years before those students can do something that's actually productive and helpful to the company. Why would you have smart students coming from top universities where it takes so long for them to be able to be useful? I would suggest that this issue of learning for transfer is one that has not been addressed, not been recognized as widely as it should be, nor the fact that we have some techniques that can actually foster learning for transfer, this level 3. Okay, well, just the overview of the classroom data. Again, that's in the learning instruction paper. I'm happy to share it if you're interested. I know you can't really see it very well, but the assessments we have of declarative knowledge here, orange is the productive failure group, and then the gray that you really cannot see at all. So they're almost equivalent, slightly higher for productive failure for the declarative knowledge. Okay, so that's fine. They did reasonably well. On the, basically we give students open-ended problems to solve, and then, but this required them to be using appropriate explanatory knowledge to be solving the problems correctly. Here we have a big effect size, significant difference in favor of the productive failure group over the direct instruction. And then level 3, we had 2 transfer problems. One was a within domain problem, a climate-related problem that they've solved about the butterfly effect. And then we had another problem that required using appropriate complexity ideas about something that they had no exposure to at all in the materials, a robot mining problem. And again, we have a big difference in favor of the productive failure folks. Now the qualitative data is interesting. What we found in just the observational data that we had, that in the PF group, that the students were really quite lively. They're talking to each other, they're talking to the neighbors, you guys try this. And so, you know, when they're working on the initial problems first, it's just a lively class. They clearly look like they're enjoying themselves. They're on task, you know, they're not digging around, you know, the teacher could be walking around and so on. But even when the teaching was going on, the students would often ask questions. What about that? What about this? And so they were clearly engaging with what the presentation was from the teachers. Now, in the direct instruction class, the entire class was quiet. The teacher's giving a lecture. You could probably tell in the picture there, many of the young women there are Asian. They know if the teacher's giving a lecture that you're going to write down notes, so they took extensive notes. Nobody asked a single question. And even then, after the initial teaching, and then they've got the computer models to work on, they've got the challenge problems, they both spent most of their time, the pairs were reviewing their notes, looking to find the right answer. She told us the right answer. They really didn't use the computer models very much. They felt that the right answer was in what the teacher had just taught them. And then they kind of found that, and they kind of then paraphrased it and used that to generate the response that they had. Yeah, there was a dramatic difference in the classroom environment that we had. Now, in terms of the theorizing that we propose in the paper for why people, you know, why we had these differences, in productive failure, a key thing that's been coming out of the work that Manu's been doing, and I'd say the work that I've been doing as well, that you know, having students initially generate their own ideas, even though they're not going to be expert, perfect ideas. They have gaps. They have misconceptions. Students a lot of times might organize their knowledge in different kinds of ways. That's what you expect. But at least they're activating ideas that they have, the pieces of knowledge that they have. And indeed, collaboratively talking, we would argue, actually, as they're doing the problem-solving stuff, helps them generate a wider range of ideas. And that's something that's come up, particularly in some of Manu's studies, as being a key thing. The wider range of ideas you come up with, the better then you're able to benefit from the delayed instruction. Because what's going on there is that the students then are comparing what they came up with what the teacher said. And for a lot of them, it's kind of like, oh, I got that, but I didn't think of this other thing, or I didn't know to call, you know, what the term for this is. You know, that this, they might describe something in a way and then find out, well, that's dynamic equilibrium. Okay, so learning the formalisms that you might have in a particular area comes out as part of this. Manu's proposed that what's happening with this comparison is that you're engaging a cognitive process of schema abstraction, which helps the students form a more generalized schema about the targeted knowledge that you want to have the students, and you know, be constructing. And a more generalized schema is what's been associated with being able to transfer, to apply the knowledge that you have. But with the direct instruction group, very quiet. We've got no indication that they were generating many of their own ideas, because they were pretty much, whatever ideas they were having, they're copying things down. So you've got a certain amount of cognitive load, and you know, get it down, and then they're going back and looking at what they wrote down. So they really are not kind of activating a range of their own ideas to be able to then construct a new kind of an understanding. Essentially what you have is a passive cognitive engagement that led to low-level learning gains for those students. They were able to get a certain amount of declarative knowledge, but not the higher levels of understanding associated with explanatory knowledge, nor the transfer. Okay, so what's all of that got to do with motivation? Okay, recall. Intrinsic motivation, you do something because it's interesting. Well, I would say the students using our stuff were pretty interested. They weren't worried about getting the problem wrong. They were just kind of excited to have their ideas and put it out there. And then when they were comparing, It didn't feel like, well, I got the wrong answer, and, put their their tail between their metaphorical legs. They were kind of saying, oh, yeah, you could kind of see a sense of some aha moments. Extrinsically motivated students. You do something because it leads to a separate outcome. Well, it really did seem, now again, we weren't expecting this, and so in that particular study, we didn't have the opportunity to do focus groups that I often like to do, but it really did seem that the students were focusing on generating an answer that was correct, that involved the use of the words that the teacher had just spoken to them. It seemed that they were doing it for an extrinsic reason. Well, see, these are all good students. Now, they're all good students and probably like to have grades, so there's probably a certain amount of extrinsic motivation there. But, typically with students that really do excel, they often demonstrate intrinsic motivation as well. So why is it that these students, for which there's no indication of any difference on pretest between we had 2 classes in each of the groups and so on, that there was any kind of difference in terms of their background knowledge or their degree of motivation. Why would we see this kind of indication of motivation, if you will accept my characterization of that? Why did the PF students seem to be acting like they were intrinsically motivated? And why the other students seem to be merely extrinsically motivated? Well, here's where I would like to say what we're observing is not motivation as something that's inside the students that then colors how they do. What I would suggest is the characteristics of designing a learning experience around a productive failure approach creates a classroom context in which intrinsic motivation emerges out of the activities that the students are engaged with. And conversely, in a more traditional kind of school, that type of a learning design, we see extrinsic motivation emerging. Not that it's a thing there, but because of this interaction between the individual and then the situated context that they're in, we see very different kinds of behaviors. Now, what might that mean? It's kind of a conclusion. So, again, what does it mean? Caveat, speculations of a learning scientist about motivation. Okay, I'm not a motivation-focused research. Still, the interest in complexity perspectives in learning is increasing. The educational psychologist paper with Manu and Peter Ryman, we were very grateful to receive the best paper for 2016 from educational psychologists. We had a symposium at the National Conference of the Learning Scientists where we invited people who use different theoretical approaches in their research, representing sociocultural, situative, embodied perspectives and cognitive perspectives, come and help us consider with the audience that we had if complexity perspectives might be of value to enhance the ways in which we can understand and theorize. And we received very, very kind feedback about that as well. So, if since motivation is something related to learning, of course, and so if there is some potential value of taking a complexity perspective, I would suggest that in some ways it has the potential for a real theoretical debate about motivation. Because it seems from what I've been able to come across that the predominant view is that motivation is a factor. It's something. We'll have certain assessments and we'll say you got this kind of motivation, you got another kind of motivation. It's something inside the student that you have and you don't have. But if we have a complexity view of motivation, that we can engender experiences that students would have. We can design for learning experiences in which the good kind of motivation, the intrinsic motivation, emerges out of those interactions. where the students are learning at a very high level while they're enjoying it. You know, the view that students only really are going to learn if you coerce them is pretty widely held, I think, by parents. Parents are still caning their kids in Singapore, for example, to get them to do better. It's shocking, really shocking. I worked there, lived there for 3 years. You know, I guess what I would say is, you know, maybe let's get some more research on this. Let's maybe have some debates go on, because they would represent two very different views, not just of kind of abstract interests, but could be of really large-scale impact in education broadly. So I had a little video, but I don't want to take up any more time. So with that, I'll just say thank you.